In this video, we are going to go over how to set up a beam contact analysis with MSC Nastran. So here, if you look at this example, we have some hexahedral elements here on the top left, then we have some quadrilateral elements here. And then for these other elements, these are beam elements. And then if we look at this from the side, you can see what the before deformation looks like and after deformation. And if we look at after deformation, we can see that the beam elements, the beam cross sections, are actually coming into contact with the other elements. So in this video, I'll walk you through how to set this up. Now, a few things. Number one, everything in this video was extracted from the MSC Nastran Nonlinear SOL 400 Users Guide. There's a chapter called Contact. There was a section on beam contact. So I recommend going to that section, maybe reading through it before this exercise so you can follow along. Also, this tutorial, this entire setup is going to be done in a web browser. So yes, we are using MSC Nastran through a web browser. If you want access to this web application, you can visit theengineeringlab.com. Here in the top right hand corner is the blue button. Click that button, fill out the free trial form, and then you'll go ahead and get access to this web application. Now, I am assuming that you already have a bulk data file that you want to configure. In this case, this model, all of the elements, all of the materials, all of the loads and boundary conditions, that has already been defined. It's already contained in this bulk data file. So here we're using SOL 101 for a linear statics analysis. The only thing we have to do now, we have to add the definitions for contact analysis. So let's go ahead and get started. After you get access to the web app, you come to the home page. Let's go ahead and click on the viewer. Here, we are going to take that bulk data file and we are going to upload it to the viewer. And there are a few ways you can configure the contact definitions. You can either define contact bodies one by one for the elements here. Here in this case, you might have 6 contact bodies and 3 contact pairs. But instead of doing this manually, we are going to use Nastran's automatic contact generation capability, or ACG, to do this for us. So let's go ahead and turn on ACG. So here in the bottom left, we'll go ahead and click on pre, go to case control commands, and then go to commands. Look for B contact. Mark the first checkbox for the above subcase level. Here, if we open this window, you notice that B contact is now on here in line 3. Next, go to configure. For B contact, set it to auto touch. So this is now going to turn on ACG for touching. So the beams are going to be allowed to touch one another. But there's one additional setting we have to do. If you go to the bulk data section, look for, here, let's click on reset table. Let's look for BC Auto P. So the BC Auto P entry is going to fine tune ACG. Here, what we want to do is look for method. And let's go ahead and use the segment to segment method. For beam contact, you do not want to use node to segment contact. Segment to segment contact is the better approach. So let's go to download and let's run this. And later on in this video, I'll explain why node to segment is really not the best solution. So right now, Nastran is running. It's automatically creating the contact bodies. It's creating the contact pairs, and it's performing the statics analysis. So here, let's do one thing. Let's turn off these markers for the contact pairs. So the markers for the contact pairs are these dotted or dashed lines. So we'll click on LBC's display panel. We'll click on hide all. So now all the contact pairs are hidden. Let's go back to post. And whenever you look at contact deformations or displacements, make sure the scale factor is 1. And now here are the results of this beam contact analysis, if you will. If we look at the first, here, let me do this. Let me turn on the cross sections for the beams. So here are the beams in their undeformed state, and then here are the beams in their deformed state. If we look at the top beams, we see that the bottom corner of the cross section is actually coming into contact with the hexahedral elements. Now for this next set of beams, it's not shown here, but the beam cross section is coming into contact with the thickness of the 2D elements. Now, for the last set of beams, this is probably my favorite part of this entire tutorial. We see that the beam cross sections are actually coming into contact, and this is noticeable when we rotate the model. So there you have it. That is how you set up beam contact analysis with MSC Nastran. Now, let me go ahead and take some time to do a few other things. Maybe you want to look at a color plot of the deformations for the beam elements. If you click on marker plot here on the top right, this is going to show you a marker for the deformation of the beam nodes, if you will. So here, if we look at this marker, if you look at the markers at the tips of the beams, you can see they have deformed the most here. And then if you want, you can also turn on some maximum labels like you see here. Okay, so now let's take a step back and talk about a few other things. Let's customize our existing bulk data entries. So whenever you run ACG, it's going to automatically create all of these contact entries. So BC body 1, B connect, BC para, BC table 1. Now, we want to keep and modify these entries to our liking. So let's turn off ACG. So we go back here to B contact. Let's turn off ACG. So let's go ahead and select BC table 0. And now we have turned off ACG. We're saying, hey, use the BC table 1 entry that was automatically created before. And let me do this. Let me see if I can do the following. Let me turn on contact only for subcase 2. So here, notice that for subcase 1, there is no B contact. We are not considering contact in the first subcase. But then in the second subcase, we are saying use BC table 1. BC table 1 points to those contact pairs that were automatically created. So that would be these contact pairs that you see on the screen. So let's rerun this. And so we turned off ACG. We customized our previous contact configuration. So let's look at this now. These are the results for subcase 1. And in subcase 1, we did not consider contact. And look what happens. The beams go straight through the other beams, which makes sense. We didn't have contact analysis, so these beams do not know they have to contact and affect and deform the other beams. So here, let me show you the undeformed and deformed shape. So again, the beams are going straight through the other beams. There is no contact in load case or subcase 1. Now, if I go to subcase 2, now I have contact on. And that's all because in the case control section, I have the following configuration. So in subcase 1, there is no B contact. In subcase 2, there is B contact, and we use BC table 1. And then you see that reflected here in subcase 1 and 2 in the bottom right. Also, whatever you do on the right side, or the left side, here, let's go ahead and change this with contact pairs. Whatever you do on the left table, it's immediately updated here on the right side of the screen. So here I can say test subtitle, and you see the subtitle is immediately updated for you. Okay, now let's do one other thing. Let me turn on ACG rather. So let's go ahead and make a few modifications here. So right now, ACG is on. And let me go ahead and modify BC or BC auto P. Let me set this to node to segment contact. And let me rerun this contact analysis with node to segment contact. So when you go through chapter 9 in the SOL 400 users guide, there's a section on beam contact. Now here, when you go through this, you find a few things. Let me see if I can find it here. When you use node to segment contact and you go through this chapter, you see this statement: contact the beams with non-beams is established at the beam nodes without any allowance made for beam dimensions. So that is a problem for us. So with node to segment contact, it's not going to consider the beam cross section. It's only going to detect whether or not the nodes and the beams come into contact. Also, there are, at least when I was testing this, there are other issues like this. Here, let me see if we do see. In this case, we don't see the beams come into contact with each other when we use node to segment contact. We still have to fine tune ACG a little bit more to get the beam contact that we want. But overall, node to segment contact for beam contact is not something I recommend. It's more difficult to use. It's less realistic in my opinion. So the better approach is to use segment to segment contact. So let's go ahead and turn on segment to segment contact. And then let's go ahead and rerun this. And let's go ahead and see if there's anything else on the agenda. Nope, we're almost done. So let's go ahead and rerun this with segment to segment contact. And we'll look at the deformation before. Right, so now we see the beams are reacting to the touching. So let's go ahead and turn on the cross sections. So again, node to segment contact, it works, but it doesn't work as well as segment to segment contact. So here, my opinion is, if you have beams that are coming into contact with one another, I recommend using segment to segment contact for this scenario. Okay then, so that's the end of the tutorial. That's how you set up a beam contact analysis for MSC Nastran. Let me leave you my contact email. So just in case you have questions, if there is a specific tutorial you would like to see, please contact me and I'll get back to you as soon as possible. And yeah, that's the end of the video. And as always, thank you for watching.